Hey everyone, welcome back to the Big Dog Podcast. I'm Lisa Saunders, and as always, I'm here with Jason Reed. Today we're diving into something that's honestly changing the way robots interact with the world: pneumatics. Jason, you ever think we'd be talking about robots with a soft touch?
Not in a million years, Lisa. I mean, when I started out, robots were all about brute force. Pick and place, heavy lifting, nothing gentle about it. But now, pneumatics are making robots, well, almost delicate. It's wild.
Exactly. That's the thing. Compressed air-driven pneumatics are letting designers build robots that can handle fragile stuff, like, I don't know, a microchip or even a tomato, without crushing it. It's all about that reduced contact pressure and lightweight design. And it's not just in factories. I was reading about soft robots being used in prosthetics and even in rehab. They're starting to show up in healthcare, helping people recover, or just making life easier at home.
Yeah, and the tech's getting smarter too. You've got these advanced sensors now. Robots can actually sense when they're being touched. I think it was Festo's CTO who said, "No other technology has such a sensitive and flexible approach to human-robot collaboration as pneumatics." That's a mouthful, but it's true. The air pressure changes, the robot feels it, and it adjusts. That's a game changer, especially if you're working side by side with people.
Totally. And I've got a story for you. There's this robotics startup I visited. They're working on automating the handling of super fragile electronics. They tried electric grippers, but they kept damaging the parts. Switched to pneumatics, added some smart sensors, and suddenly they could pick up these tiny, delicate boards without a scratch. The engineers were honestly relieved. It's like, sometimes the simplest solution, air, turns out to be the best one.
That's the thing, right? Everyone wants to overcomplicate it, but sometimes you just need a gentle squeeze. Pneumatics do that better than anything else. And I might be wrong, but I think we're just scratching the surface with what these systems can do in robotics.
So let's talk about why machine designers are all in on pneumatics. It's not just the soft touch. There's sensitivity, sure, but also strength, speed, and the fact that these systems are lightweight and compact. You can build a robot arm that's fast and precise, but it doesn't weigh a ton or take up half the floor.
Yeah, and don't forget toughness. I mean, I've seen pneumatic systems run in places where electrics just can't hack it. Dust, heat, you name it. Actually, I remember this one factory, super dusty, like you'd wipe your hand on a machine and come away looking like you'd been mining coal. The electric actuators kept failing, just couldn't handle the grit. We swapped in pneumatics and suddenly no more breakdowns. They just kept running. Less wear, less overheating, and honestly, less headache for everyone.
That's a great point. And for end users, it's not just about reliability, there's safety too. Pneumatics don't spark, so you can use them in places with volatile stuff in the air, like mining or food processing. And if you need clean air, you can get ISO 85731 Class 0 purity with the right setup. That's basically as clean as it gets. Perfect for surgery robots or anything in healthcare.
Yeah, and the cost side matters too. Lower initial cost, less maintenance, and you don't have to worry about downtime as much. Plus, if you only need a little airflow, you can go with a smaller, low-pressure system. It's scalable. I always say, if you want something that just works, go pneumatic. Unless you like fixing stuff all day, then sure, stick with electrics.
Laughs. I'll take less fixing, thanks. But seriously, it's that combo. Sensitive enough for delicate work, tough enough for the worst environments. That's why you see pneumatics everywhere, from warehouses to hospitals.
All right, let's get into the heart of it. How do you actually power all these pneumatic systems? Rotary screw compressors. That's the backbone. If you want steady, pure airflow, low maintenance, and energy efficiency, you go with something like Kaishan's KRSP or KRSP2. They're built for this stuff. No pulsing, no weird pressure drops, just a constant stream of air. That's what you need for sensitive controls.
And it's not just about the machine, right? You need local expertise. I mean, you can buy the best compressor in the world, but if it's not installed or maintained right, you're going to have problems. That's why working with professionals, people who know compressed air inside and out, makes all the difference. They help you size it, set it up, and keep it running. It's not just a sale, it's a partnership.
Yeah, and I've seen that firsthand. There was this plant in the Midwest. Old compressors, constant downtime, everyone frustrated. They switched to rotary screw compressors, got a local team to handle the install and maintenance, and suddenly downtime dropped way off. They saved a ton on repairs and lost production. Sometimes it's not about the fanciest tech, it's about having the right setup and the right people backing you up.
That's what it comes down to: reliability, efficiency, and support. Rotary screw compressors give you all that, and when you've got a good partner, you're set up for the long haul. I mean, Cation even backs their air ends with a lifetime warranty. That says a lot about confidence in the tech.
All right, I think that's a good place to wrap it up. Pneumatics are changing robotics, rotary screw compressors are making it all possible, and if you want it to work, get the right people on your side. Lisa, anything else before we sign off?
Nope, I think we covered it. Thanks for listening, everyone. We'll be back next time with more straight talk on compressed air and automation. Jason, always a pleasure.
Right back at you, Lisa. See you next time on the Big Dog Podcast. Take care, folks.